Hello class 10. Let's learn about pair of linear equations in two variables. Linear equation in two variables. A linear equation is an algebraic equation in which each term is either a constant or the product of a constant and a single variable. Linear equations can have one or more variables. The general form of linear equation is ax plus by plus c is equals to 0, where a, b and c are real numbers and a and b are not both 0. In the equation right over here is quite known to us because we already know about linear equations in one variable. But now we will learn about linear equation in two variables. The two variables here are x and y, and a, b and c are constant values. Since a and b are both associated with the variable x and y, therefore they are also known as the coefficient of the variables. A is the coefficient of x, b is the coefficient of y. For example, if we take the linear equation minus 2x plus 3y equals to 9, then we can divide this linear equation into three parts. Each of these parts are known as terms. Minus 2x plus 3y and minus 9 each are terms. Since the general form of the linear equation is ax plus by plus c is equals to 0, and in this equation we can see that on the right hand side we have a constant 9. That means it is not in the general form. Therefore, to bring it to the general form we have to bring 9 to the other side, that is left hand side, and therefore this term will become negative, that is minus 9. Hence, the terms right here are as it is. Now, if we break down the terms, these consist of two parts. One, constants, and secondly, the variables. For minus 2x, minus 2 is the constant value and x is the variable. Minus 2 here is also known as the coefficient of x. Minus plus 3 is the coefficient of y. But since minus 9 is not associated with any variable, we will call it to be a constant value. Every linear equation involving two variables in the equation, a solution means a pair of values, one for x and one for y, which satisfy the given equation. For the equation 2x plus y equals to 5, we can put the value of x as 4. So considering the value of x as 4, let us rearrange the given equation in terms of y. So here we can see y is equals to minus 2x plus 5. We have got this from this particular equation. Now let us put the value of x as 4, and after solving it we are getting the final value of y as minus 3. So hence we can say the pair of values or the ordered pair which satisfies the linear equation in two variables is 4, minus 3. 4 being the x coordinate and minus 3 being the y coordinate. So what we can tell from here is that a linear equation in two variables will always have their solution in pairs of values. One will be for x, another will be for y. Pair of linear equation in two variables can be represented by the general form as a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 is equals to 0, where a1, a2, b1, b2 and c1 and c2 are all real numbers, and a1 square plus b1 square is not equal to 0 and a2 square plus b2 square is not equal to 0. So from the general equation we can see that both the equations are having the same variables x and y. So if we take a scenario where we are creating variables or equations based on same conditions where x and y are those conditions, then we can get a pair of linear equations. For example, 2x minus 3y plus 4 equals to 0 and x plus 7y minus 1 equals to 0 can be considered as a pair of linear equations in x and y. Using tables to list the solutions. So for an example, if we take 2x minus 3y equals to 12 as an equation, then we can write down the solutions of x and y of this equation in the tabular form. So for the value of x equals to 0, we will get y equals to minus 4 in this equation. Similarly, for x equals to 6, we will get y equals to 0. And for x equals to minus 3, we will get y equals to minus 6. If we just put the values, we will see that the answer is coming out to be 12. So after getting the solutions in the tabular form, we can write down in ordered pair form. So the coordinates of the solutions will be 0, minus 4, 6, 0 and minus 3, minus 6. We can also take 3 and minus 2 as another solution. We can take one more example as we are talking about pair of linear equations. Therefore, we are taking one more equation as 2x minus y equals to minus 1. And we can list down the solutions like this as 0, 1, 2, 5 and 3, 7. And mark them as ordered pairs in the coordinate form. Now let us plot the ordered pairs on the Cartesian plane. First of all, we have to write down the scale at the top right corner, which is very important. For this particular graph, we have taken one small division is equals to 1 unit. Then we have to begin at the origin, then use the x coordinate to move to the right or left of the axis. From that position, we can move either in the positive or the negative direction according to the y coordinate along the y axis, and then place a dot to indicate a point on the plane. So, for example, 0, minus 4 can be plotted on the y axis in the negative direction. We can also plot 6, 0 on the x axis in the positive direction, and also minus 3, minus 6 can be plotted on the graph paper in the third quadrant, like this. Remember to highlight the point which you are plotting. So now we can join these points using a straight line. So this straight line represents the linear equation. Let us plot the points which is on the second linear equation, and we can join it with another straight line. So here what we can see is that the two straight lines are intersecting at this point. So what we can say that there is one point which is common solution of both the linear equations. So these type of lines can be said that they are having one and only one solution for the pair of linear equations. So there is only one solution for both of these straight lines, that is there is only one point through which both the linear equations pass. So these type of lines are, or pair of lines, are known as intersecting lines. So intersecting lines are those lines which have only one solution because at only one point these two pair of lines are intersecting each other. Thus they have only one solution. Coincidental lines or coinciding lines are such lines which overlap each other. So since both the lines are overlapping each other, we cannot distinguish between the two lines. That means every point which is lying on the first line will also lie on the second line. So actually we are having infinite number of points here, 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 everywhere, which lies on both the lines. So they are actually the same line and crosses at every point. So they have infinite solutions or infinite points which lie on both the linear equations. Lastly, we have parallel lines. These lines do not meet each other at any point. They constantly have a constant perpendicular distance between them, and these two lines keep on going without meeting anywhere. So as a result, we can see there is no such point at which both the lines are passing through. Therefore, we can say they do not have a solution. The pair of linear equations do not have a solution. Individually, the lines have infinite solution, but there is no common solution between them. So we can write that they have no solution. Based on this, we can say that linear equations can be consistent and inconsistent. When we talk about consistent, we mean intersecting and coinciding. That means for intersecting, we have one solution. For coinciding, we have infinite solutions. So if we have any solution, maybe one or infinite, does not matter, they will be consistent. The pair of linear equations will be consistent with each other. But for parallel, we don't have any solution. That means for inconsistent linear equations, we do not have any common solution or any solution for the pair of linear equations. So for consistent, we will have solution. For inconsistent, we will not have any solution for the pair of linear equations. Now, without drawing them geometrically, we can also say whether a line is intersecting, coinciding, parallel, consistent or inconsistent based on these conditions. So from the equation, if we take the ratios a1 by a2 and b1 by b2, then we can check whether they are equal or not. If a1 by a2 is not equal to b1 by b2, that means the value of the ratios are not equal, then we can say that those represent a set of intersecting linear equations. If you take out the ratio a1, a2, b1, b2 and c1, c2, and if it appears that all the ratios are equal, say for all of them the ratio is half, a1 by a2 is half, b1 by b2 is half and c1 by c2 is also half. In such cases, we can say that the linear equations are coinciding in nature, that is, they are consistent. Similarly, when we take out the ratios as a1, a2, b1, b2 and c1, c2 and see that the first two ratios, that is a1 by a2 and b1 by b2 is equal, but that value is not equal to c1 by c2. That is, if a1 by a2 is half, b1 by b2 is also half, but c1 by c2 can be 1 by 4 or 4 by 1, anything. In that case, we can say that those lines are representing parallel linear equations because the first two ratios are equal, but the third ratio is not equal to them. Hence, they are parallel in nature. That is, they are consistent. Thank you everyone. Hope the video was helpful.